I forgot to mention the pros and cons of the scenario analysis in the last video, so I'm going to do them here. One great thing about scenario analysis is that it allows you to change more than one variable at once. So if you think sales or the unit price is going to drop, then unit sales might rise. So you can change multiple variables, or I should say uncertain variables, at the same time. A serious con of sensitivity analysis, or sorry, scenario analysis, is that it's, again, you only look at a limited number of outcomes. I only looked at 3. I could have done, the second best and the second worst outcomes, and for a total of 5, but I chose not to. You don't have to stop at 3, but it's unlikely that you're going to manually go through and do many of these possible scenarios because it's just kind of time consuming to program them. There, in recent years, I'd say the last probably 30 years or so, especially the last 20 or 10, since as computers have gotten a lot more capable of crunching large amounts of data at once, we have been using something called simulation analysis or Monte Carlo simulation to analyze a project's standalone risk. So I am just going to copy this scenario analysis and make some adjustments to it, and I will call it simulation. Unfortunately, you can't do this unless you have a special add-in package to Excel called At Risk. And I've activated mine, and you can see it adds a whole new menu to Excel. It's it's not that expensive for what it does. I can't remember exactly how much it costs. It's a few $1,000s, but for a corporation, that's not much money at all. In the olden days, you used to have a programmer whose job it was to program all of this into a mainframe. And I'm going to just delete all of this because we don't need it anymore for this particular tab. And I'll pop this to simulation. Okay, with simulation analysis, essentially you tell the spreadsheet which variables are uncertain and how uncertain they are. So I'm going to just highlight in yellow the uncertain variables. And actually I'm going to pop them back to their original numbers. So that was 75 units. This was 350. $1.25 a unit. And this 2% constant growth rate. So now we're back to our original $404,000 NPV. And I will just highlight those values. I could also change my discount rate that I have. I have it just programmed into my net present value, but I think right here I'll put discount rate, and we originally used 15%, and I'll just create a link in my net present value formula to this cell. So if I change this to 10%, it will change my NPV. But for now, I'll put it back at 15, and so that will be another uncertain variable. Remember, I've got 20% and 25% programmed in here as my growth rates. I could change those, although I'm not going to right now. So what you would do is choose all your uncertain variables. Then you would program the add-in, the Excel add-in, and you'd tell it how uncertain each variable is, which will make a little more sense as I start to do it. So essentially I have to look at this variable, daily units, and I go over to the add-ins, the at-risk menu, and I define my distribution. So essentially I can tell it that that I think the number of units sold would be a normal distribution, a higher likelihood of achieving the mean, a lower likelihood of achieving values on the tail end. Or maybe I think it's a uniform distribution, so an equal likelihood of accomplishing any of the values in the range that I input. Just to demonstrate the two, I'll do daily units as a uniform distribution. So I will choose it and select it. And I'm not sure you can see this really well on the video, but I can't make this any larger. When I choose the uniform distribution, have to enter the lowest and highest values I think it's possible to achieve. So let's say I think the lowest value would be to sell, I don't know, 25 units a day. And the highest would be able to sell 90, well, I don't know, 112 units a day. And here it says static value 75. That's just the original value I had typed in. So I've got those inputted, and I can just say OK. Now I input a distribution for the unit price. For that one, I'll use the normal distribution to show you how to input things for that. When you input a normal distribution, you enter the mean and the standard deviation. So let's leave that mean at $3.50, and then the standard deviation, so it's saying standard deviation is 35 cents. Let's make it slightly lower. Let's make it just 25 cents. And OK. Then I define my distribution for variable cost. On that one, I think I'll make it a normal distribution with a mean of 12.5 cents. I'll just go ahead and leave it at that. That's constant growth rate. I will make a uniform distribution and input a minimum value of 1% or 0.01 and a maximum value of 0.04. And then for the discount rate, I'll again use a uniform distribution, and I will enter a minimum value of 10%. Actually, I have to make it I'll go 0.10, and a maximum value will go of 17%, 0.17. So I've defined distributions for all the yellow uncertain variables that I'm interested in evaluating. So I'll say A would be to define distributions. B is to define your output, or as at-risk calls it, add output. So basically, I need to tell it what cell I'm interested in knowing the value for when it changes all these uncertain things. So that cell is my net present value. So I'm going to click on my net present value and say add output. And it tries to guess a name. And so essentially it's just the project NPV. I can also define correlations. If I believe that price and sales should be correlated, I can input a row, essentially. So if I think they're highly correlated at 75%, or 0.75 as the row, I can input that relationship for these two variables. I'm not going to bother doing that, but I want you to realize that you can program in relationships between variables if you believe they exist. I also need to tell it how many iterations I want to do. An iteration essentially means that Excel is going to look at all these uncertain variables. For daily units, for instance, I'm telling it it's got a uniform risk pattern, a uniform distribution with a minimum value of 25 and a maximum value of 112. So what it will do right now is run through 100 different iterations. It'll start the first iteration. It will randomly choose a value between 25 and 112 for the daily units. Then it will go down here to unit price at the same time it's doing daily units, and it will follow this distribution, the normal distribution, with a mean of $3.50 and a standard deviation of a quarter. And the likelihood, knowing there's a 68% chance that the value would fall within plus or minus 1 standard deviation, and a 95% chance the value would fall within plus or minus 2 standard deviations, and so on. So it will choose a value for the price. At the same time, it'll choose a value for variable cost and the constant growth rate and the discount rate, and it will come up with a net present value. Then it will start the second iteration, choosing another value for the daily units, another value for unit price, and so on. And it'll calculate the net present value. I want it to run, let's say, 1,000 iterations. So now if I did everything right, I just click Start Simulation. And in the old days when our computers were pretty slow, this took a while, but you can see that it finished very quickly, and it ran those 1,000 iterations. And the information that it has for me, I don't, again, know if y'all can see that very well. It tells me the lowest net present value was $14,519.61. The highest was $914,000. The average net present value was $389,000. It tells me the mode, the median, the standard deviation. I can scroll. See if I can get this to work right. If I could scroll exactly to 0, there we go, I did it. And all the way over here, it would tell me the likelihood of the project's net present value falling in this range. My range is from $0 to $999 or $995,000, since these are in millions. There is a 100% chance of generating a value in that range. So that tells me that this project is, again, has an incredibly high likelihood of generating a positive net present value. Most of the time that's not the case. Most of the time, if I set this left arrow on 0 and the right arrow as high as it would go, it would have a probability less than 100%. If I were interested in knowing the likelihood of earning at least $300,000, I can move, I don't know if I can get it perfect, but there, it worked. I can move my counter or pointer or arrow to $300,000, and it tells me there's a 63% chance of generating in excess of $300,000. So again, this just lets me get a feel for how risky this project is, and I can make a decision as to whether I should undertake it or not. So, just to finish up my text box here, once I add my output, I determine the number of simulations that I want to run, or iterations. And then finally I run my simulation. And unfortunately, none of these risk management techniques or risk analysis techniques give you a clear-cut decision. You have to evaluate and interpret the data and make a decision as to whether the project's too risky for you or not. In this particular case, the project generated positive net present values essentially all of the time, so it looks like a no-fail project. And I probably shouldn't have demonstrated one like that, but I didn't actually know ahead of time it was going to turn out that way. So the pros of simulation analysis is that I can evaluate many possible outcomes. The at-risk add-on that I'm using lets you do 10,000 iterations. So I'll say up to 10,000 with the at-risk add-on that I'm using. I can also program interrelationships between variables. So if I think price and number of units sold are related, I can program that in. I'm going to take a quick look at the... Oh, okay. I can... like if there's a variable that I think is uncertain, but it's not nearly as uncertain as another variable, I can program in different degrees of variability for the different variables. So I can allow different variables to vary at different rates. So I could just set a tighter distribution for less uncertain variables and a wider distribution for more uncertain variables. The con, I guess, of Monte Carlo simulation is that it takes a little bit of knowledge to figure out how to do this programming. It's not that difficult to learn, though. So I'll say not quite as easy as some of those other methods. But it's a lot easier, a whole lot easier than it used to be. Again, like 30 years ago, they didn't have these Excel add-ons and they had to hire a programmer to program all this stuff and run the iterations on a mainframe. And back then, you saw how quickly it ran 1,000 iterations in just a matter of seconds, but even 10 years ago, it would take like 30 seconds to a minute for it to run all of those. So 30 years ago, it took it a long time. And there's no clear-cut decision, but that is a problem that all these methods have. And what I mean by that is you have to evaluate the output and make a decision as to whether or not to undertake the project.